from Yamaha Robotics, and today I want to talk to you about our new Allen Bradley ladder logic integration concepts that we've developed here at Yamaha Robotics. And so behind me I've got an Allen Bradley L1 Compact Logix PLC. This is the lowest cost Compact Logix that you can purchase today. It doesn't have SIP motion in it, so what we're going to be doing, or what I'm going to be demonstrating today, is the ability to communicate from a Compact Logix directly to our RCX 240 controller via Ethernet IP. And over here I've got a YK150, 150mm SCARA. It's one of our second to the smallest SCARA. And I also have a Panel View 600 just to demonstrate that. So let's kind of get started here. What I'm going to show you. Basically, what we're finding out is, people have a couple of different control philosophies as we show them these new concepts. Now, these are new kind of control concepts that maybe you haven't seen before, so I want to kind of introduce them a little bit in sort of two different philosophies that we're finding. I'll go ahead and turn my robot on. I'll power it on. And I have a panel view here to kind of assist me via ladder logic, and I'll also show some ladder logic here. So I'm going to go to the next screen, and I'll set my speed to 15% so I don't hurt myself, and then go into auto. And then my first demonstration screen here basically has two different screens where I can move the robot to point 1 and move the robot to point 2 at a certain speed. And on my screen here, I basically have these two AOIs. I have the Move P AOI right here, and if you don't know what an AOI is, AOI stands for add-on instruction, and since version 16 in RS Logic Studio 5000 software, Allen Bradley has given the ability for third-party vendors to add add-on instructions to be able to control their devices, and that's what we've taken advantage here at Yamaha Robotics. We've written and tested and beta tested our own AOIs that we can directly control our robots via ladder logic. So let me show you one philosophy on that. Now, philosophy number one would be some customers actually like the look and feel of a pendant. Sort of the six-axis robot world has kind of ingrained that in most of the customers. And so they prefer to jog the robot with the pendant and teach points. And so in that philosophy scheme, we have the ability to store the point value in the robot. And if I press move to point 1, you'll notice that my SCARA moves to point 1 on there. If I hit move to point 2, it does that basically via point-to-point command, if you will. Philosophy number 2 is a little bit more high-end or more powerful. So let me show you that integration style here. My next screen here is what we call a move millimeter or a move millimeter coordinate AOI. And I'm going to show you here in my ladder logic. I'll scroll down here to the move millimeter block. Okay, the move P millimeter block accepts an input of X, Y, Z, and R coordinate values. So what I'm going to do is I'm going to go ahead and fix these to where my SCARA will move my tool. So if you know anything about a SCARA, we're actually going to move the endpoint or the tool of the robot 0x150Y, and we'll put a 0Z and a 0R in that. And when we press move to point, we have the robot actually move to that world coordinate value. Okay, so along with that, that kind of gives us a great deal of flexibility now. Rather than storing the points in the robot controller, we can actually create points in our PLC. So I've got a screen set up here where I can do remote teaching of our robot here. And what I'm going to do is I'm going to actually turn the servo motors off on our little SCARA. Okay, and now that allows us to move it by hand freely. And also, we can now grab the values from the robot and store them into registers in the PLC. So what I'm going to do is I'm just going to teach a quick little pick and place program, 5 points, and I have a point register indexer here on the panel view, and I'm going to store the home position into 0. So I'll just set the robot anywhere I want, and I'm going to hit teach position. And we're grabbing the values of the robot right now and storing those into the PLC. I'll go ahead and index my position to number 1, and I'll teach my first pick position. I'll go ahead and teach it there, let's say, and I'll teach that, and then I'll raise the quill by hand, and I'll index it to number 2 and hit teach. And then I'll move the robot to the place position, the down place position, which will become number 3, hit teach. And then I'll index it up to 4, move the quill up, and hit teach. And there you go. I just taught 5 positions in, I don't know, a matter of less than probably 30 seconds. We can go back and review the timing on the video. But I think that's a very quick and efficient way that you can have the full integration or show the power of using the PLC, the touchscreen, without having to pick up the pendant, without having to learn Yamaha programming, without having to go to Yamaha school and use the pendant, things like that. So these are some of the advantageous features of a fully integrated AOI ladder logic solution that we're offering here at Yamaha. So let's continue with our demo and show you how we replay those points. Actually, let me turn the servo motors back on. Turn the robot back on, so now the robot's kind of stiff again there, it's ready to go. So we'll go ahead and move the point, and there's our home position that we taught. We'll move to the first position here, number 1. I'm getting too fast, but number 1, that's our pick position. Number 2 is the above pick position. Now we'll go to the above place, which I believe was number 4 on that. And then number 3 is the down position to place the part, and then 4 would be the above on that. Okay? So there you go. We basically taught positions freehand, recorded them into the PLC, and replayed the values.